Hey guys, quick follow-up to that last video where I explained how to do logistic growth rate calculations, right? And so before I explain it right now, I just want to give a quick example using some numbers. Okay, so I have my graph here. I have population size. I have time. Okay. I have an organism. Okay, the max growth rate of this organism per capita is 2 per capita per year. Okay, so every organism can result in 2 more organisms per year. Okay, so like if I have 2 of these Snorlaxes mating, right, they must make 4 babies on average, right? So each one of them is responsible for 2 new babies. That's what that's saying. Okay, so in the year 2019, utilizing my graph, right, I had 156 Snorlaxes. Yeah. And so the question then that I would pose to somebody might be, what amount of Snorlaxes would I expect to see in 2020? Okay. And that's where I use that formula
Please
that I
excuse the
discussed.
interruption.
Okay.
Tenga un buen día. Have a great day.
These announcements, they kill me. So I pose the question, how many Snorlaxes would you expect to see in this population in 2020? Okay. And so I take my max growth rate per capita, which is 2. I multiply it by the current population, which is 156. That gives me 312. Okay, so that's how many I would expect to see if nobody died. Right, that's my growth rate if nobody dies. Okay. Then I take into account my carrying capacity because, as you can see, whoa, this population is already at carrying capacity. It can't really hold any more organisms than it already has. Right, so clearly not all my growth rate is going to be realized, right? There's going to be Snorlaxes dying in this population because there's not enough resources. Okay? And so I figure out what my rate of change in consideration of my carrying capacity is, right? So I know that my carrying capacity is 150. I'm above that, right? So I can expect that my population is probably going to go down this year, right? And so I expect this value to be this number here, right? So it's 150 minus 156, which is 6 divided by 150 gives me negative this, right? Okay, because this is a negative value divided by this, I get this, negative this. Okay. So this value, my positive change, right, multiplied by my value that considers my current state in relative relation to my carrying capacity, okay, gives me this value right here, negative 12.48. That's my expected rate of change for this year. Okay. So in 2019, I had 156 of these organisms, of these Snorlaxes. Right? I expect to lose this many. And so in 2020, I expect to have 143 and a half Snorlaxes. So I'd have somewhere in that range. Obviously, I can't have half a Snorlax. Right? And so that is how we use that formula. Cool? Cool. Bye.